Probably need them. For the record, so it's official. You probably already saw it on Canvas, but just in case, UH Volumes Quiz 30 is now live. That's the one I'll be picking up next week or the day before. UH Volumes Quiz 30 next week or a day before the exam. 6 days from now. You'll be fine. You'll be fine. All right. Yes. Right before the exam. So Wednesday, the 26th. All right. Here we go, guys. So this question here is being taken from UH. So this is the type of question that you'll have. It says, sketch the region bounded by the curve. So let's just sketch the curve. We got a whole page. So in a little bit, I'll sketch the real region that we're looking at. So here's just an approximation of my sketch. It's not going to be a good one. So y equals 2 squared of x. So it starts at the origin. Looks like that. This guy right here, that's just the same thing as saying y equals negative x plus 8. So I start at 8 and I just draw a linear line like that. Not to scale. I'm saying that's 8, right? Negative 8 plus 8 is 0. So there it is. And the y equals 1, it looks something like that. So the region we're interested in is this region right there. It kind of looks like a shark fin. And that's what I'm going to rotate about the x-axis. So let me sketch that again. But this time I'm just going to sketch that region. Let's see. So it looks something like point. And then I'm exaggerating it, of course. It looks something like that. And then when I rotate it, let's see, point there, point there. Not the best. I can tell that my rotation for the bottom one is way larger than the one on the top. But you know, I tried to make it work. So when you do a slice, notice this slice. I'm going to do the slice right at the biggest. When I do that slice there, dang, I knew I forgot again. I keep forgetting to go to Walmart to get you guys some washers. Okay. It's a washer. You don't see the washer? But this time, so here's what you got. This is what makes this question kind of tough. And by the way, I put AP questions here so you'll see the difference between this one and the other. There are two different integrals for this one. Do you guys notice? It's two separate equations. One equation all the way, a washer all the way until you hit the max, and then until you hit the highest point there. And then it's a different style of washer with different equations after you pass that. You guys notice that? So you're going to need a calculator. So let's just put in the calculator just so we can see. What do I need? The negative x plus 8 and the 2 squared of x. So 2 squared of x and negative x plus 8. And I guess you don't need it. Window 0. Yeah, that's fine. Negative 1. You know what? And y equals 1. All right. I need all three of these intersections. Second, calculate number 5. Enter. Yeah, it'll give me this one. So this one on the top is 4. This one on the top is x equals 4. This one over there in the very far left is that a second? Calculate 5. Let's see, what curve am I looking at? Yep. Enter. The y is a 1. Guess. Boop. 0.25. So far and we could have probably solved it algebraically, but you know. And then that's let's see, the y is of 1. So what's that? 9. I think that's 9. But just to check really quick. Second, calculate 5. Nope. Yep. And yep. Oh, 7. I can't add. 8 minus 1, 7. You could have solved it algebraically, guys. You could have just said this. That's the line y equals 1. This is the line x plus 8. So you could have said they have the same y value. See? 1 equals negative x plus 8 minus 8 minus 8. Oh, yeah. I'm so dumb. You could have just solved it by hand. It wouldn't have taken you that long. Yeah, you're right. Don't say that. I think I have allergies because I don't think I'm sick. I think it's allergies. All right. Anyways, so there it is. Those are the 3 values that I want. So it's a washer. Remember, guys? So I'll go ahead and put the visual just in case. Remember, when we find area of a washer in geometry, that's here's a big R and here's a little r. So pi big R squared minus pi little r squared. Some of you are including the pi in the integral. That's fine. I like to factor it out, and then you just have this. Look, big R squared minus little r squared. That's how, well, this is how you get volume. And remember, it's in terms of x. So give me don't put literal r squared. Put it in the expression for what r squared is. All right, so here it is. I'm going to write volume equals, I have 2 integrals. So the first one is going to happen from 1/4 to the value 4. And the big R, so what's the big R? So let me go ahead and put it in green here so you guys can see. So I'm looking at that green washer here. In a little bit, I'll change it to a purple washer after we pass that. So the big R is the distance from the x-axis to the top of that curve. That curve is 2 squared of x. So I'm going to write giant parenthesis, little parenthesis, 2 squared of x, close squared, minus, and the little r is always, in this case, 1. Put the square in there, guys, so the reader knows that you know that you're doing big R squared minus little r squared. And I'm going to add plus integral from 4 all the way to 7. Now it changes. Let me go ahead and do that washer. So this is a washer in purple here. So the big R is the linear line, parenthesis, negative x plus 8. Negative x plus 8, close it, squared, minus, and then the little r again is still the 1. Put a pi, I forgot my pi's. Put a pi right there, put a pi right there. Oh, and I didn't put an extra parentheses. You're right. Well, I don't need it, but I'll put it. All right. We probably could do it by hand, but let's just do it with a calculator. So I'm going to put the pi's on the outside, guys. I'm not going to put the pi's until the very end because notice all my answers have pi's in them. So I'm going to do it first. I'm just going to do it by hand here. Or is it easier to just type those into the calculator? I already have them in the calculator, right? Y1, Y2, Y3. Yeah. So let's work smarter. I already have them in the calculator. Y1, Y2, Y3. So here we go. I'm just going to go math 9 from 1/4 to 4. And let's see. It was that one. So y1 squared, the way I have it in here. Alpha trace y1, enter, squared, minus 1 squared. And I guess you don't have to put that 1 squared. You don't have to put the squared, but I would anyways. Plus math 9 from 4 to 7. And I believe I have the linear line in y2. So I'm going to use y2 second, all the way over there. y2 squared, alpha trace y2 squared, minus 1 squared. And then I'm going to push enter. And I'm going to turn it into a fraction. And there it is. Put the pi next to it, 369 pi over 8. Volume is 369 pi over 8. There it is, letter B. And that's how it's going to look on UH. Cool or not cool? Okay. All right. It's the same as we've always tried. The only difference now is we're not rotating about the x-axis or y-axis. So relax. It's the same logic. Just don't be a robot. I'll show you how to be a robot if you want to be a robot, and you'll never get it wrong. But try not to be a robot. Let me do it first without a robot, and I'll show you how to be a robot. But I don't want you to be a robot. The region between the graph y equals square root of x and the x-axis between 0 and 9 is revolved about the line y equals 5. Which integral will determine the volume of this solid that is generated? Okay, let's do a sketch. Sketching always helps. And we got the whole space, so yeah, that's fine if we do. All right, so here it is. Here's my first one. So y equals square root of x. So here's y equals square root of x. I'm exaggerating it. And I'm only looking between 0 and 9. So here's 9. And it says is revolved about the line y equals 5. Okay. I'm gonna make 9 over here. Oh man. And I'm gonna say 5 is. I'm gonna say y equals 5 is like right. Can I move all this down? Where's my little hand? There we go. I was expecting it to. It didn't do it. That's fine. Let me do it again because I'm going to rotate it about y equals 5. All right, here we go. Round 2. You're good. If you have the sketch, you're good. Here it is. Here's my square root function. Here's y equals 5. And here's 9. So what you're doing, imagine at y equals 5, imagine this is like a spindle or something that you can rotate, right? So imagine you're here, you're spinning this, so it's going to go boom. So reflected, instead of the x-axis or y-axis, reflected across the y equals 5 point. So let me see. That point equal distance, probably here. And then this is 5 away, so 5 away, probably like right there. So then, there it is. So how does it look? This is blank. This is hollow. And if I slice it right down the middle, bam. So there it is. This is hollow. You can take a dog through it. A what? A puppy. Oh, it doesn't matter. I was gonna say cat, but whatever. And then this is not hollow, but this part in here in the middle is hollow. Kind of looks like those chimneys from the nuclear plants, but inverted, where this is hollow and this is solid. You guys kind of see it? This is hollow right here. Okay, here we go. Don't worry, I'll teach you a little bit how to be a robot, but first I don't want you to be a robot. All right. What shape is this cross section, guys? It's a washer. Volume equals, all right, guys, focus. Volume equals pi, integral from 0 to 9. These are all dx's. And now here comes, quote unquote, what a lot of people think is the hard part. I need to find the radius. Do what you think is easiest for you. The radius, the big R, is the distance from here all the way to that top one. I'm not going to use that one because that's the image that I inverted. So I'm going to use this from here all the way to there. So what's that distance always? 5. So I'm going to write 5 squared. Giant parenthesis, 5 squared, minus, open parenthesis. Now I need my little r. So let's think. The little r, and I'll color code it. Let me color code it. The little r is this guy right here in purple. So I want, bless you. I want this guy here in purple. So to get that guy here in purple, I got to go this distance and then subtract how much I've gone up on that curve, right? So it's going to be this minus the square root of x. Do you guys see that? So that's your little r right there. So I'm going to go 5 minus the square root of x, close it, put a square on it. And there it is. Close it dx. And now we look for that answer. So let's see. Letter A, it says, which of the integrals will determine the volume of the solid that's generated? Not letter A, not letter B, letter C. Probably. I don't see any issues with that one. Letter D, there's an issue with letter D. They didn't square the 5 out. And is there an issue with letter E? Yeah, what's the issue on letter E? They're putting a plus in there. So what's the answer? Yeah, see? So now you see how we do it. This one's coming from Delta. We gave them the credit. And relax, relax. We're fine. We're fine. Find the volume of the solid obtained by rotating the region bounded by 6 minus y squared. That's that curve right here. That curve right there is x equals 6 minus y squared. And the line x equals negative y, that's this one right here. X equals negative y. You can also say y equals negative x. Same thing. About the line x equals 8. So we're rotating about that. So here is the region that we're rotating. When I rotate that region, I'm going to try really hard to draw it. Remember, I got a D in art, guys, so I'm not the best. And let's see. That one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 away. So 10 away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Boom. So it looks something like... Not a very good graph, but that's fine. It looks okay. I've done better graphs. I'm kind of tempted to not connect it. Looks something like that. Looks something like that. When you do your slice, always do your slice in between that, right? I'm gonna cut it right down the x-axis here. So here's my slice. So we should be noticing two things. Chav, what are those two things? One, that slice is a dy, not a dx. See, it's horizontal, it's a horizontal slice. That's a dy. That's the difference in y. And two, when I make my integral, it's going to be in terms of y's. You know what I mean? Because it's a dy, not a dx. Yeah, this little, I guess the difference in that's a dy. And we're adding up an infinite amount of cross sections. Do you guys see that, guys? Okay, so here we go. This is it. Oh, by the way, it's a washer. So what should we notice? That it's a washer. So it's gonna have this look. It's gonna have pi integral a to b big R squared minus little r squared with a dy. So in terms of y. It's going to have to look like that, guys. Are we still okay? All right, here we go. I need to figure out, what do I need to figure out? I need to figure out this intersection value, and it looks like it's a perfect one. What is it, -2? And I need to figure out this intersection value. What is that, 3? Because I'm integrating with respect to y, guys, so I need my y value of where they intersect. Say it again, Kandura. I was pointing out where they intersect. The lowest intersection point.
Oh, down there.
Yeah. That looks like -2, and then that one, the highest intersection point, looks like 3. Verify it, though. Verify it. Chop, how do you verify it? Well, these two must be equal. They must have the same x values. So when x is -2, do I get the same x value of 2? So let's see. -2 squared is 4. 6 minus 4 is 2. Yep. And opposite of -2 is 2. Yep, it works. Do you guys see that? So just verify it really quick. When y is 3, I better get the same x values. 3 squared is 9. 6 minus 3 is -3. Yep, -3. That looks like -3. And then plug in a 3 in there for y, and yep, turns to a -3. So we're good. It works. Cool or not cool? All right, here we go, guys. Volume. Pi on the outside Integral from what to what? Negative 2 to 3. Big R. Okay. What is the big R? You try to use your image. Try to use this image here, the original. So here's how you can be a robot, and never get it wrong. If you want to be a robot, you'll always get it right when you do this. Here's your washer, rightmost minus leftmost, and for your big R, and then your little R is just rightmost minus that curve, and it's always gonna work. Like always, always, always. Yeah, little R is this guy right here. Axis of rotation. I should have said it like that. If it's not the x-axis or y-axis, if you want to be a robot, axis of rotation minus the farthest curve. That's for big R. Axis of rotation minus the closest curve. That's your little R. Put a square on it, and you can always do that, and it'll always be right. Let's do it with logic. Yeah. So here it is with logic, and hopefully the logic you'll see is repetitive. Axis of rotation, big R. The distance from here, this is my big R right here. Do you guys see how that's the big R? So from here to here, so how do I find that distance? Axis of rotation, 8 minus whatever this curve is. Do you guys see that? The furthest curve for the big R. Axis of rotation minus the curve that's furthest away. That's your big R. What's the little r? Axis of rotation minus the curve that's closest to it. There's your little r, that guy right there. Do you guys see that? So here it is. Axis of rotation. So I'm going to open up a parenthesis. Another one. Axis of rotation. What's the axis of rotation? 8. And I'm subtracting the furthest curve, which is the linear line. So the linear line is negative y. So minus negative y. You can put plus, I guess. Put a squared. But see, there it is. You won't. And it makes sense. Oh, yeah. It's 8 plus whatever that is. That's y. But just do it like that. 8 minus negative y. And then plus, parenthesis, 8 minus, and then the one that's closest. The one that's closest is the quadratic. Parenthesis, 6 minus y squared, close squared, dy. And I'll explain it again. Why are we what? Oh, you're right. It's not added. Why did I put plus? Plus 1 point for you, miss. Yeah, you are no robot. Who's the one that gave me that? Who told me that? Was it you? Was it Ronald? It was. Oh, where to go, Cepeda? Plus 1 to Cepeda. I added to a test. Yeah, good catch, miss. I'm gonna add a point to your test. If you don't see the plus 1 point, tell me. Oh yeah.
Let me just take a picture of that.
Well, it says it in the notes. It says it on the notes. Plus 1 for Cepeda. Yeah, big R squared minus little r squared. Does everyone understand this? Okay, so this is look, the distance between here and here, that's 8, and you're subtracting whatever, that's how you get that number. And then 8 minus whatever this curve is, and that's how you get this little guy. Cool? Or not cool? Not cool? All right. Say it again. All right. When you're typing this into the calculator, guys, the calculator doesn't care what letter you use. So I would just type it in like this. So here it is. I'm going to go pi, math number 9, and I already forgot my limits. Negative 2 to 3. Negative 2 to 3. And then open up a parenthesis, and I'm going to write 8 plus y, and minus a negative, but 8 plus x, close squared, minus, open up another one, and then this one I'm not going to change anything. 8 minus 6 minus x, okay. 8 minus, parentheses, 6 minus x squared, close squared. Okay, I think I got everything correct. I think I didn't mess up. You guys check my work. 785.398. That's the volume. Yeah, sometimes you get weird numbers. This is coming from Delta. Do they want the pi? No, nearest thousandths. I don't see any issues. I think that's correct. Cool or not cool? Sorry. Okay, check it out, guys. We're finally getting to questions that we can do from the AP exam. This is question 2005, question one from the 2005 exam, calculator. So if it's a calculator question, look, they gave names to the equations. The first thing I would do, I would type this one into Y1 and I would type this one into Y2. Do not use calculator language on the exam, or any exam for that matter, but type it into Y1 and Y2. So do that first. And everyone try, guys. Everyone try. Clear. I already forgot the equation of Y1. What was it? 1/4 plus sine of what? Pi x. Sine of pi x. Okay, there's my Y1. What is Y2? By the way, make it look like this. Don't have my habits. That's an ugly habit. Yeah, you know what? Let me make a good habit. Alpha Y equals enter 1/4. And then delete. Okay, I think we're good now. Y2 is 4 to the negative x. 4 to the negative x. All right, here we are. Let's see, window. When you make your window, make it look like the one that they give you. So it looks like, so let me see how it looks like normal. 0 to 5 or 0 to, let's do this one. Okay, I got to really zoom in there. So I'm going to go window, and I'm going to go to like 1.2, and I'm going to go to like 1. And let's see how it looks now. All right, I'm missing a little bit, so I'm going to go to 1.8 for X max, and I'm going to go to 1.8 for Y max. All right, good enough. Good enough for me, I think. Yours doesn't look like mine? All right, here we go. Let f and g be the functions given by f of x and g of x. Let R be the shaded region in the first quadrant enclosed by the y-axis. And the graph of f and g, let S be the shaded region in the first quadrant enclosed by the graph f and g as shown in the figure to the right. Okay, so sorry guys, I have issues with the formatting. Try to read that with that. All right, letter A. Find the area of R. So they want this. So they just want the area of R. So I'm going to say R equals. I can tell right off the bat that the lower limit is 0, but I do not know what the right limit is. So I take my calculator, and I'm going to look for that intersection right there. So I'm going to go second calculate. Second calculate. Number 5. Enter. And then I'm going to scroll to the one I want. Enter. All right. 0.178218. All right. How are you going to show this on the AP exam or on any exam? All right, check it out. Here's how you do it, guys. You see how this is a calculator question? You do not have to solve anything by hand. All you're doing is this. You know what are the two functions, f and g, so you're going to go 1/4 plus sine pi x, and you're going to go equals 4 to the negative x. And you're just going to go, that is x equals, and then give me the number. So that number, there's two of them actually, right? 0.178218, put as many digits as you can. Oh, man. 0.178218. Did I write it correctly or no? 178218. Okay. I'm going to store this to A. Let's do the other one because we're going to need it eventually because I see letter B. And you see that one? For the next one, I'm going to go x equals. And I'm going to tell the calculator to do the same thing, but with the other one. Second, calculate number 5. Enter. Guess. Scroll to the right. Crisscross this time. Oh, that's just a 1. X equals 1. That one doesn't need any special lettering. Leave it as 1. I guess I could have looked at it and just figured that out, but that's fine. All right, here we go. 0 to A. You already labeled what A is. A is at 0.17828. What graph is on top? G of x. And they give you the name G of x, so use it. G of x. What graph is on bottom? There it is. And then make sure to put the differential, your dx. and then just give me the answer. So I have that on Y2 and I have the other one on Y1. So here it is. Oh, I haven't saved it yet, huh? Dang it. And I already put 1. So that means it's going to say X equals 1. Number 5. Enter, enter. Yeah, I didn't store it. Did you guys store it? Man, see, you guys are better. I think it's because I have allergies. I think that's why. X store alpha A. All right, there it is. I took care of it. I took care of business. Math 9 from 0 to A. And what's my top curve? I think I have it saved in Y1, right? Oh, I have it saved in Y2. Dang. Alpha trace Y2 minus Y1. There you go. And there it is, guys. Did you guys get that answer? Okay, so for full credit, what do I write? 3 decimal places. You have options. On this one, you have option. You can write it either as 0.064 or you can write 0.065. If you're not, I don't know which one. Type all the digits in there. You're fine. 0.06475. 0.06475. We'll look at the rubric in a little bit. All right, let's figure out the second one. Find the area of S. I'm going to go S equals. You're safe now. Integral. What do you mean by chop? What do you mean by safe? I already labeled this A, so you can keep using A throughout the whole duration of the problem. My lower limit is A. See, that's where I start. And I stop at 1. 1 doesn't need any special. I mean, I guess you could if you wanted to, but don't. It's silly. Upper minus lower. Let's use the names. F of X minus G of X. Make sure to put the differential, dx. Some of you forget to put the differential. That might cost you. It depends, right? Depends on the situation. It could cost you a point. Math 9, alpha A, all the way to 1. And then I'm going to go y1 minus y2, alpha trace. Never use calculator language when you're writing this out. We just put y1 and y2 in our notes for notes purposes. 0.410, and that's the only way you can write it. If you want to write more digits, go ahead. 0.410. Are we still okay, guys? All right. Chop, where's the volume question? I haven't seen it yet. Here it is. Find the volume of the solid generated when S is revolved about the horizontal line y equals -1. There's the curve. I put it in there for you again. Do a sketch. So it doesn't have to be perfect, guys. It never has to be perfect. From doing the reading all these years, I've noticed that the kids that are getting these correct are the ones that are doing the sketches because they can visually see it. And I'm not saying the kids that don't do the sketch don't get it right. Most of them do. But the ones that are definitely getting wrong at a higher percentage are the ones that are not. They're just, So here it is. Here's y equals -1. And I'm rotating it about that. So let's see. I'm using that point. So that point is like right here. I'm going to use the maximum. And let's see, that point, stretch it right here. And then this point. And then this point here is like right there. All right, so it looks something like it doesn't have to be perfect, guys. That's actually pretty good. Probably one of my better ones. Here's my slice. Let me do my slice better. My slice is not perfect, but that's fine. What do you notice? It's a washer. Yeah, it's a washer. Don't be confused. The middle is not the x-axis. If we want to be robots, we're just going to do upper minus lower for big R. For little r, closest curve minus axis of rotation. Remember, guys? All right, here we go. Upper minus lower. You can always do axis of rotation minus upper too as well. You'll get the right answer, even though it's not the best format, but that's still fine. I guess the best format is depends on your point of view. All right, volume equals pi. Integral, what's my lower limit? What letter did I use last time? So it's still A. There's still A. You can still use it. Once you've used it before, once you've called it A before, you can use it all the way you want. All the way to what? 1. All the way to 1. big parenthesis, open up another little parenthesis. My big R is the distance from, so what's the big R? The distance from the way up there all the way to axis of rotation. You can say axis of rotation minus that. That's fine. But I like to use logic, and this is big R right here. So is this a curve minus that negative 1? Do you guys see that? So I guess it turns to a plus. The rubric probably will have a plus. Yeah, I'll say it again because I think I did it too fast and I thought some of your opinions. Okay. Big R from this distance all the way to up there. So remember, how do we find that gap? Well, it's that curve, whatever that curve is, minus that negative 1. Or I guess you could think of it as 1 plus whatever that curve is as well. Do you guys see that or no? Okay, perfect. Do you see it? Okay. What happened, Kuduro? Ask me.
It's not the line.
It doesn't matter because you're going to be squaring it. So if you want to say negative 1 minus f of x, you can say that. But I see it as f of x minus a negative 1. So yeah, I'm gonna write it as f of x minus a negative 1. Close it and square it. That's big R. Some of you might think of it as, oh, well, the distance from the x-axis to that curve is f of x, and then add 1 because of the axis of rotation. You can think of it like that too. Minus giant parenthesis or little parenthesis. The little r is this distance right here. I'll do it in purple. That's little r right there. That curve is g of x. G of x minus negative 1. Child, that should be plus then. Like, yeah, that's fine. Close the giant parenthesis. Bam. Dx. All right, here we go. Ready? Take your calculator. Pi math alpha or math 9 alpha a all the way to 1. And then I'm in here, I'm going to type in, let's see, open parenthesis. And then what was my f of x? Did I have it on y2? y1? So trace y1 minus, so negative 1, so I'm going to put plus 1. Close it, squared, minus alpha, oh, let me open up parenthesis first. Parenthesis, alpha trace y2 minus, or negative 1, so plus 1 again. Close, square it, and do I need another parenthesis? It's already there. X. If I didn't do any mistakes, 4.558 or 559. That was going to have or. What was it again? I already forgot it. 4.558. Let's see if we got all 9 points. This is how your test is going to look, by the way. Similar to this. It's going to be just 3 free response questions. Maybe 4. All right, 2005. So let's look at the rubric, guys. Do you guys like looking at the rubrics or no? I haven't looked at this rubric yet. All right, here's the rubric. There it is. 9 points always. Letter A. Did we get 0.064 or 0.065? Notice they did what we did. Oh, man, why did they choose small cap this time? They chose the letter A like we did, but they chose little a instead of capital A. I just go capital letters all the time. A, B, C, D, just down the line. Whatever habit is your habit, it's fine. Letter B. Did we do this? 801 f of x minus g of x. Did we get 0.410? Yeah, we got those points also. So there it is, 6 points. And then letter C. Perfect. They wrote it the way we wrote it. We did the minus negative 1, which is plus 1, but it's the same thing. 4.558, 4.559, integrand, limits, and constant and answer. There it is, guys. 9 points. Cool, right? Very cool. All right, let's keep going. I know. We're almost done. We got one left. Yep, this is it. All right. Again, this is area and volume. So number 2, let f and g be the functions given by, and they give you that. This is a calculator question as well. So the first thing I would do, I'm going to type this one into y1. I'm going to type this one into y2. So let's do that real quick. 2x, 1 minus x. 2x, parenthesis, 1 minus x. Okay, what was y2? 3, 3x minus 1. Square root of x on the outside? Square root of x. It's a little weird, but okay, that's fine. We got everything we need, y1 and y2. Find the area, the shaded region enclosed by the graph f and g. Okay, pretty basic. They already give me the limits from this picture. It looks like that's a perfect 0. It looks like that's a perfect 1. So I'm going to go area under the curve is going to be 0 to 1. And then use the name. That's on top. That's on the bottom. So I'm going to write f of x minus g of x. And I'm just going to dx. Because it's a calculator question, do I have to show any antiderivatives or anything? No, this is called the setup. You just give them the setup, give them the answer. That's it. Setup and answer. So math 9, 0 to 1. And I'm just going to go alpha trace y1 minus alpha trace y2. And if I didn't make any mistakes, that should be it. 1.1333333. Oh, that means that you can actually turn that into a fraction if we want. 1.13, right? 13, yeah. 1.1333. How do we feel? Yeah, good. Letter B. And this is the last one, and we're done. Find the volumes of the solid generator when the shaded region enclosed by the graph f and g is revolved about the horizontal line y equals 2. Okay, it doesn't have to be perfect, guys. So here it is. I'm just going to copy and paste it and check it out. My drawing is going to be crappy. How much do I want to take? Half the space. So I'm going to leave this half to write and the other half to sketch. So here's my sketch. I'm going to go... And I'm going to say here's y equals 2. It's not to scale. And it's going to look like, let's see, point there. So point here and point there. It looks crappy. It doesn't have to be perfect. All right, let me make it better. Still not satisfied. Okay, that looks okay. Here's my slice. Bam, slice. What's the shape? It's a washer. It's a washer. Big R is this one in green. Check it out, Stella. If you want to be a robot. Pi integral 0 to 1, big R, axial rotation, minus that curve. 2 minus whatever that curve is. What curve is that? G of x. Minus, and then little r is the axial rotation, minus that curve that's closest to you. All right, guys. Try not to be a robot. Can you be a robot? Yes, you can, but try not to be a robot. So here it is. Volume. Volume equals pi on the outside. This is a washer. Integral from what to what? 0 to 1. Giant parenthesis. Open up another little parenthesis. My big R, the distance from the axial rotation all the way to that bottom curve. So I'm going to go 2 minus, what is that bottom curve way down there? G of x. Close it, squared, minus, so right now I just closed the big R. Open another little parenthesis, little r. Little r is this guy in purple right there. Axial rotation, 2 minus, what curve is that one right there? F of x. Close, square it, close the big thing, and then put a dx for your differential. All right, let's see what that volume is. So I'm going to go pi on the outside. Don't forget the pi, guys. Math 9, 0 to 1. And then open up a parenthesis, and I'm going to go 2 minus f of x, which I have in y1, I believe, right? Oh, it was g of x? Okay, my bad. Alpha trace y2. And then square that dude. Get out of there and square it. Minus, open parenthesis, 2 minus alpha trace f of x. Close it. Square it. And did I need a brown parenthesis on the outside? No, because I already have it there. And then put an x. And voila. 16.179. 16.179. Let's see, which one was this? 2004? FRQ2. All right, so let me go to 2004 real quick, guys. And I believe this was a 3-part section, but I deleted one of the parts. Why did I delete one of the parts? Okay, don't worry about it. We'll get to it when we get more experience. All right, so here it is. Letter A. Did we get 1.133? All right, look at letter B. It's 4 points. Limits and constants. And then 2 minus g of x. Yep, we did it exactly the way they did it. Minus 2 minus f of x with that squared. Perfect. And did we get 16.179? Oh, look at this. I love that. No, 0.2 of integral, not a form. Oh, never mind. I thought they were going to give us a point for if it was in that form. Or maybe they do. Oh, no. They're saying that they don't give you anything. All right. How do we feel? All right, guys. Now we just got to practice. If that made sense, that's cool. Where's your practice? It's on Delta. So log in. You're going to need your calculator. And we're done.